Okay, welcome. This is going to be a second method for calculating the kerf cuts. This is mostly just all calculations. The field measurement would be maybe take a micrometer and find out what this thickness is right here, this 0.1. So that's a field measurement or a shot measurement. The kerf is the thickness of the blade you're using here. A is the inside radius, B is the thickness of the material. This one here you've measured. Almost time to crash. This thing's getting slow. So that's weird. Yeah, see, it's getting real boggy, but yeah, it's really not working too great. All right, so those are the field measurements. I got them here. I'll up and zoom out a little bit. I try to get all this screen. Alright, so this is just to show you at the end how you can put it on a table saw, get your kerf cut, and then you just jump. It's sort of like finger joints or box joints. They get the same gauge. And then so you got the ID. Actually, get rid of this. This is something else. So A is the angle that you enter into Excel. ID is the 18. That's what your radius is. This is, imagine they're putting the holding concrete, or it'd be opposite if it was holding concrete on the outside. But the same measurements would be you'd be starting out with 18 3/4 on the outside. But thickness is 3/4. You're going to enter that. Kerf width, you're going to enter that, and then bend thickness. Bend thickness is, for lack of a better word, just the thickness of the material that's left over. And let me go through this real quick. So 18 3/4, you're just adding those, the 18 plus the 3/4, and then you're going to find the theoretical radius of this radius right here. This one here. So let's go Control I. Yeah, it's getting pretty boggy. So the radius is 18.65. That's the 18 3/4 minus the 0.1 right there. And then you have 29.2954. 29.2954. And then the ID circle. So this is the theoretical circumference, right? That's the offset from the outside. And then the interior, ID the circumference length of this one inside here, put that in there. It's going to be 27.39. 27. Ooh, I don't know why that's different. 20 length, 18. Oh yeah, see right here, it changed right there. All right, so the full 90 degrees, 28.27. 20.27 theoretical circle minus the outside. So you're going to take the ID circle, the theoretical circle, the length of the theoretical circumference, 28. No, this one here. Theoretical radius 18.65, right? And then you're going to find the theoretical circumference 29.29, that one there. So you're taking that theoretical circumference and you're subtracting the interior diameter or interior dimension. ID circ 28, right? This one here. And then you're going to get this leftover 1. That's the difference between the theoretical circumference and the interior circumference. And then what you need to do is you need to divide that by the 16. I don't know that I showed the 16th. This it's not so, but you're going to take this, what's the difference, and you're going to divide it by the width of the blade, the kerf width, and it's going to give you 16.33. You're going to round it down. You're going to get 16, and then you're going to take the OD, the outside diameter circumference, right? You're going to take this one 18.75. And then you're going to you're going to calculate the circumference of that, and then you're going to, where I think we already did 29. No, 29. No. So there you go. That's the circumference of that, and then you're going to divide it by 16, and that's going to give you the gauge, this 1.84, right? The length of the in between, and you have to do that on the outside. You have to divide that outside diameter by that 16. All right, so 29.45 divided by 16 will give you this. So let's go into the Excel, and I'll just show you. This is input, enter. So you can see by right up here, there's no formula, right? All the purple ones, enter, enter. Those are the ones that kerf width, enter, bend thickness. That's probably a field measurement or a shot measurement with a micrometer. And then, so you know the thickness of that material pretty accurately. And the OD radius, so that's going to be the 18 plus the thickness of the material that you're using, right? Actually, I can take this. Bet you I could take this whole thing here. Control C. One of the things that works pretty good on this, I don't know if it's perfect, but it works really good. I can go Control V and I can paste that whole page right here. So let's do this. Let's open that up a little bit more and then open that up. All right, so that's just the outside radius. The theoretical radius is going to be, you're going to take the 18 plus the thickness, and then you're going to subtract the bend thickness, that 1.1, enter, and then you're going to go 2 pi times the radius. So let's do this. 2 pi times the, I don't know where to get the theoretical radius, right? Times, and then you're going to do 90 divided by 360. That'll give you the ratio of what the circumference is to the whole circle. So it's 2 pi r, and then you're going to multiply it by the fraction of the circle. That's what the B2 divided by 36, 90 divided by 36, 360 I mean. And then you got your 2 pi, and it's the same thing. It's just getting the interior diameter, interior circle, and interior circumference of that angle. Here you're subtracting those two, subtracting the interior from the theoretical, gives you the point 1, and then you're going to do the difference. You're going to divide that, right, this by the thickness of your kerf, and that's going to give you how many times that kerf goes into the difference. Going to round it down, round down to the 0. It'll give you no decimal places. And then you're going to take the OD, the outside diameter. So this dimension here has to be divided up by the outside dimension. Technically, it's probably the difference between the two right in the middle, because some of it, like if you did any bending in the metal, you split the difference. The radius, the circumference is actually the difference between the outside and inside. It's the middle. So it would be theoretically right here. Because some of the fibers are getting compressed and some of them are stretching. So it would be, technically, it would be right here. Draw, into right there. 0.03125. That'd be a 32nd. It would be this right here, right? Or 0.05. 0.1 divided by 2, right? That would be the actual length right there of the bend. So you maybe want to change that a little bit. I'm not even sure, but no, it's not quite so precision as some of that might be. And then that give you, then you divide that by the rounded down number, right? And it'll give you the gauge 1.84. And that's it. There's a second way to do the kerf cut radiuses, and I hope that helps you in your career. And again, thanks for watching. Have a great day. Till the next time. If you got any ideas, any stuff that you can figure that you've been trying to figure out that's been in the field like that, just let me know. It's not the kind of thing you got to get in school. All right. Have a good day.